Chapter 15 introduces a new data structure that is known as a list. To review, an atomic object consists of elements which all have the same data type. So that data type might be, for example, all logicals or all characters or something like that. The data structures that we have seen to date are a vector, a matrix, and array. All of these are atomic data structures. They will create objects which are atomic, and all of the elements have the same data point. Same data type. In this chapter, we introduce a fourth data structure, and it's known as a list. In the next chapter, we'll introduce another data structure, and it's known as a data frame. To review the data types we've encountered so far, from the least amount of information to the most amount of information, start out with null, and that is an empty object, followed by logical, which can be true or false only, followed by an integer, which is usually defined by putting a capital L after an integer. That's followed by numeric, which handles floating point values, followed by complex numbers, followed by character strings. In this chapter, a list is going to be defined, and it is an ordered collection of objects, each of which are known as components. And as you'll see, the subscripting is a little bit different from what we've had in the past. The components in a list are atomic objects, so each component is atomic, but from one component to the next, you might have different data types. The syntax to define a list is to call the list function, and then you name the first object, name 1, you name the second object, name 2, etc. So let's go ahead and define a list, and we'll call this one list 1. Not a very original name, but here is the list, the call to list. And now I can put in various objects into this. Let me start out by putting in maybe a vector. Let's go 1 through 8. There's a vector of numerics. And here's another numerical value. We'll put in pi. But then you can put in a character string. It was the best of times. And then you can put in maybe a complex number, 4 minus 8i. You could put in a logical value. Let's put in false. And if you wanted to, you could put in maybe a matrix. Here is a matrix of all 9s, and it is a 2 by 2 matrix. I think that is eclectic enough. We have a lot of different data types in there. And silently it's put in. If you look in the upper right here, when it says list 1, it will let you know it is a list of 6 components, and it does not list them out here. However, I can come right back into here and type in list 1, and it will, that worked out just perfect, didn't it? In terms of the space, it will list out the first component, and the syntax it uses here is a double bracket for the first component, and you can see that first component here is the 1 through 8, and that's the vector that was defined up here. The second component of list 1 is pi, and that is 3.141593 to 7 digits accuracy. The third component of the list 1, is it was the best of times, and there's that. The next component is the complex number 4 minus 8i, and there it is. Fifth component is the logical value false, and finally the sixth component happens to be a 2 by 2 array that consists of all elements, which are 9s. So there is a list with a number of different elements, and one question you can ask right away is, how do I get to these elements? And there's a little bit of a hint given here by the double brackets. That's how you do subscripting in a list. So for example, if I want to see the sixth component of a list, I would say list sub 6 in that fashion. And that was the wrong thing. The name of it was list 1, not list. So when I ask for list 1, I will get that matrix. Now, if I want to extract a particular component of that matrix, I would again do rows and columns. And for example, if I want the second row, first column of that particular 2 by 2 matrix, I would get it in that fashion. Let's look at list 1 one more time. So there's list 1. I hope you have the pattern here. If I put in list 1 and I say I want the first component, let's do that. And let's say I want the fifth element of that first component, it will come up here and return 5 as the fifth element of the first component. If you were to ask the question, is dot atomic list 1, it would answer the question, is list 1 atomic? Do they all have the same data type? And the answer is false, because it's a mix of data types. It is numeric, it is complex, there is a component in there that's a string, there is a component in there that's a logical, etc. Here are a couple more questions we can ask concerning list 1. We could say, what are the names associated with list 1? And we haven't given any names to these components. We will in a second example coming up. Next one, what is the class of list 1? It will tell you that list 1 is a list. What is the length of list 1? It has 6 components. So the length function here will return the number of components. One last thing, there is a list command, but there is also an unlist command. I could say unlist list 1, and when I do that, what will happen is it will do automatic coercion, and all of the elements in list 1 will be reduced to character strings. So quotes will be put around all of them, and you can see that they are ordered 1, 2, 3, 4, 5, 6, 7, 8. The 9th element is pi in quotes. The 10th element is the character string. The 11th element is the string that consists of the complex number, etc. At this point, a new list is going to be defined. So let me put the sweeper up here, and let's define list 2 in a different fashion. Still going to use the list function, but this time I'm going to set the first element, x, going to name it also, to 1:6, and then after that I'm going to let y be the built-in string month dot abbreviations, and I'm going to let, I'll call this z complex, be 4 plus 3i. So now if I type list 2, you will see there are 3 components, but now instead of a 1 in double brackets, you can see there's a $x. So that x has been inherited as sort of a metadata that sits above all this. Y are the month abbreviations, and you can see here's $y, and then z complex is $z complex is the single complex number. So now what I'm going to do is I'm going to see if I can take a look at some of these elements. So for example, if I say list 2 sub 1, I will get all of those elements in the first component of list 2. Another thing that I can do is I can use what's known as the $ extractor. So I could say list2 $x, and it will know to go to this component right here. You can see fewer keystrokes in this case, and that's another way of getting to those values. Still another way of getting to those values, you can actually put in a character string in as a subscript, and it will say find those associated with X. And those are all the different ways of getting to that first component of list 2. Keep in mind that if I go to any of these, I can attach on, for example, I want the third element of that vector, and it'll come and it will extract that third element. That pretty well lays out all of the different things you can do with a list. This is an important example right here because it allows you to name them and it allows you to extract them with the $ extractor. So for example, if I type list2 $y sub 4, it'll give me the abbreviation for the month of April. So lists are the first non-atomic element or non-atomic data structure that we have seen, and it is the fourth. We now have 4, which are vectors, matrices, arrays, and now lists. In the next section, we will look at a new data structure, which are called data frames.